Hey guys, just want to take a couple minutes here and give you a little bit more instruction on how to complete this AP handout worksheet here, which deals with asymptotes and limits. There is the one example there. However, it might be helpful to have just a little bit more instruction on how you do this. So I'll go ahead and do maybe 2 or 3 more here. So in all of these, it's going to give you some information about a limit. That limit is either going to be as approaching a value equals infinity, or the limit is approaching infinity equals some value. So the first thing you have to determine if this is talking about vertical or horizontal asymptote. If you want to remember, a vertical asymptote is always going to be the limit as x goes to some c equals plus or minus infinity. Horizontal is always going to be limit as x goes to plus or minus infinity equals some c. So they're kind of switched there. Vertical, limit as we go to a constant equals an infinite value. Horizontal, limit as we go to an infinite value equals a constant. So definitely is important to keep those straight. With that said, let's go ahead and try to answer a couple more of these. Let's just start with number 1. So the 2 things it gives us are these 2 here. We're supposed to explain what this tells us about the graph. So both of these are one-sided limits. As we approach 3 from the left, and as we approach 3 from the right, we're going to positive infinity and negative infinity, respectively. So what's happening here is we can say as x gets closer to 3 from the left, first of all, y coordinates go to positive infinity. So you could just use the same structure with all of the problems if you want to. It doesn't have to be this exact wording, but you could use this general structure. So we're saying as x gets closer to 3 from the left, so approach 3 on the left side, y coordinates go to positive infinity. The other one we would say as x gets closer to 3 from the right, y coordinates go to negative infinity. Something like that would be a good explanation. Then the next thing is, well, is there a vertical or horizontal asymptote? So this is talking about vertical asymptotes, right? Because we're going to some constant and we're getting a positive and negative infinity value. So there is a vertical asymptote. Yes, the equation of that would be vertical. We're talking about x value, x equals 3. So that's our first one. Let's skip down a little bit harder ones, maybe further down. Let's go ahead and do number 4 here. So first of all, our explanation. So we could say as x goes to positive infinity for the first one, y coordinates or y values approach 2. And the other one we could say as x goes to negative infinity, y coordinates approach 4. So this limit value down here is always an x value, and then the equals part is always a y value. So if you can just keep those straight, you'll be on the right track. As x goes to this value, y coordinates approach or go to this value. As x goes to this value, the y coordinates approach this value. So it's pretty straightforward in that. Let's now try to answer our questions here. So this is talking about horizontal asymptotes because we're going to infinity. So as we go to positive infinity, x is going to, or y is going to 2. So we're going to have y equals 2 is a horizontal asymptote. And as we go to negative infinity, it's actually going to be the opposite. Y is going to 4. So what's happening here graphically? Horizontal asymptote at 4. We don't know what this function looks like. Here's, let's call this y equals 2 and this y equals 4. We don't know what this function looks like. Maybe it looks like, say positive infinity is 2, so maybe it goes like that. And then the negative direction, maybe it's up here, and it goes like that, approaches 4. So that could be something what the function looks like. All right, and let's maybe tackle one more. That one looks fun. All right. Let's save the real hard one for you guys. Let's look at number 6. The limit as x goes to 1 equals positive infinity. So as x approaches 1, now this is from both sides because it's saying the overall limit. So as x approaches 1 from both sides, y goes to, or y coordinates go to positive infinity. And then the other one, we could just say at x equals 1, comma, y equals 4. All right, so what does that tell us? Well, the x equals 1, y equals 4, probably what's happening here is we have, we might think is like some sort of a break in the graph, and then you've got that filled in with at 1, it's defined to be 4. So let's try to draw this. I think it helps a little bit here. So if we just mark 1 on our graph, as we approach 1 from both sides, this is going to go up to positive infinity. So it goes up like that. All right. However, it says that f of 1 equals 4. All right. So this is kind of a unique situation. I don't think you'll see this very often. But you have a dot that basically fills that in. So we would still say that there is a vertical asymptote at 1, even though it's not continuous. So this would be discontinuous because we would have to sort of jump from that unbounded infinite value to 4. However, there is a vertical asymptote. It might seem kind of weird to have that dotted line through the filled in dot, but we would say that this is still a vertical asymptote because it's just simply saying that the function approaches some unbounded value from either side. So our vertical asymptote, would still be yes, and the equation would be at x equals 1. All right. As far as the last part here, you're supposed to write basically 11 limit statements based on this graph. So if we were to, I would take the strategy of just working from left to right. Just start here and just sort of work your way this way. And you need as many limit statements as you can come up with. There should be 11, including 1 and 2-sided limits. So just to get you started, the first one that I would say would be the limit as x goes to negative infinity equals, and well, it's basically saying as we go this way, what does the limit equal? And you can see it's actually approaching 0, right? There's a horizontal asymptote essentially there at 0. You can't see it because it's a solid axis, but that is there. And then the next one I would do would be the limit for this one. You would do a left limit. I would do a right limit coming in here, and then I would do the overall limit. So I would say, I'm not going to tell you the answers, but I would say the limit as x goes to 0 from the left, the limit as x goes to 0 from the right, and the limit as x goes to 0 overall. It's okay if one of them doesn't exist. You could still write that as a limit statement. So come up with as much as you can there. I believe there should be 11. Reach out to me if you are still struggling with any of this, and good luck.